I think I was cut off at the end of the last recording where I was talking about factorial and how we can put the number that we want the factorial of in a variable, and we can use a variable in the Boolean expressions to control these loops. How we still have our loop counter and we're still having to have another variable that we default to 1 because we're doing multiplication. If we use a 0, we'll never get an answer other than 0. And that's accumulating the answer for us. And we print the answers out at the end of each loop, and this works. If you prefer to count down from 5, or rather from the number so you're going to go 5 times 4 times 3 times 2 times 1. If you prefer to do it that way, you certainly can. So you start out your counter at the number, which in this case is 5. You flip the Boolean expression here, and you're going to loop as long as I is 5, 4, 3, 2, 1. And you're going to take 1 away, so you're going to go 5, 4, 3, 2, 1, and you're going to get your answer. Or you could loop as long as it's greater than 0. Any of those will give you the correct answer. You could also reverse this as well. You could start I at 5. You would loop as long as num is greater than 0, for example. And you would subtract 1 here. So you can do the same thing in a while loop. And you should get your correct answer. So I wanted to also cover the Fibonacci sequence, and if you've ever read about that or used that in any math classes, you know the first two numbers we start out with are 1, and then we add 1 plus 1 and get 2, and then 1 plus 2 to get 3, and 2 plus 3 to get 5, and 3 plus 5 to get 8, and 5 plus 8 to get 13, 8 plus 13 to get 21. So we're adding two numbers to get a sum. Then we add that sum to the one prior number, get the next sum, and then we add that new sum to the prior number to get the next number in the sequence. So let's say we want to print out approximately the first 10, or exactly the first 10 numbers in the sequence. This one I like better in a for loop because I know I want it to run, and I want it to run X number of times, in this case 10, and print everything out for me. Now the trick with this one, the hardest part is right here. So, and the other hard part is making sure you set up 3 variables. You're going to need 3 variables to help you keep track of where you are in the sequence and to keep track of the sum. So I've got sum here. I defaulted to 0. Then I've got num1 and num2. So I'm going to think of this as num1 and num2, 1, 1. Then that's my sum 2. Then I'm going to think of 1 and 2 as num1 and num2, and my sum is going to be 3. Then I'm going to think of 2 and 3, 2 being num1, 3 being num2. I'm going to add them to get the sum. That's kind of how you have to do it. So setting up the loop is not that big of a deal, and I sort of borrowed a little bit of code from somebody's project, and I apologize, I can't remember who it was, but I liked how they had set this up. So this is another case where we're going to do something a little different. We're not going to start our counter with 0. We're going to start it with 1. And then we're going to loop for the first 10. So as long as our counter, which we're calling sequence number, is less than or equal to 10, we'll loop. And we'll add 1 to that counter. So we go 1, 2, 3, 4, etc. so that we get the first 10 numbers. We're not going to print sequence number out. In this loop, sequence number is not going to really be used for any math or for any printing. It is literally used to make sure the loop executes 10 times so we get 10 numbers in the sequence. But make no mistake, we're not using sequence number or its value anywhere in the loop. This is one of the few times that we've done so far where the sequence number is literally just a counter to make sure the loop runs exactly 10 times. What if I did start with a 0 here? Well, I would be running the loop 11 times. I would be getting 11 numbers. So I should get one number past 55, and I do. So in this case, we're going to start with 1 so that we get our 10 numbers. If you decided to start with 0, you would loop until less than 10, right? To get 10 actual numbers, or you would loop until 9, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 10 times, 10 loops. But it's more logical to start with 1 and loop for 10 times this way, so we'll do it that way. So we're going to start out with the first two numbers being 1 and 1, so we get our 1 and 1 printed out, and then we get our correct sum of 2. And then we'll flip and we'll take the sum and make it the second number. We'll take the second number and make it the first number. We'll swap more or less here. So I'm going to print out the first number, which is going to be a 1. Then I'm going to add num1 and num2 to get my, which is 1 plus 1 in this case, to get 2. Then I need to throw away the first num that's in num1 and replace it with the second one that's in num2. And I need to replace the 1 in num2 with the 2, with the sum, so that I'm set up to add 1 plus 2 next and get 3. So I come back into my second time looping. Num1 is now still a 1. I print out the second one. I add 1 plus 2, I get 3. Then I move the numbers around again, and then I loop again, and I get my 2 printed out, okay? Because num1 becomes 2, num2 becomes 3. So in that way, I'm constantly swapping. I've got these two numbers. I throw away the first. I make this num1 and this num2. I add them up. My sum is 3. I throw this one out of num1. I move 2 to num1. I move 3 to num2. Then I print. Then I get my sum of 5. I get rid of the 2 in num1. I make 3 num1. 5 becomes num2. Then I print. So that's a little tricky. Feel free to use this code to get it working. The hardest part on this one is the swap right here, and understanding where to put the print line so that even as these values are changing, I get the right one printed out. Now, one of the other assignments was to simulate rolling a 6-sided die and to roll it a random number of times. So each time I run the program, it rolls it a different number of times, maybe 10 times or 90 times or 13 times. And then I wanted to accumulate or track how many times did I roll a 1, a 2, a 3, a 4, a 5, a 6. So remember on this one, the first thing to do is make sure you import the random class. And you've got to set up a random object so we can do the next int to simulate the die and to figure out how many times we're going to roll. I don't think it's specified in the write-up the range of times for rolling, but I'm going to use 1 to 100. So I wanted to pick a number between 1 to 100 for how many times it's going to roll. So I set up a little variable for how many. I use my random object and I use the next int. Remember, 100 will give me numbers from 0 to 99. I really don't want to roll 0 times, so I'm going to put +1, so now I'll get numbers from 1 to 100. And then just so I know, I printed out how many times it's supposed to roll the die. Now I have not finished this. I will leave it to you to finish this out, but I've set up accumulator variables to hold the number of 1s, the number of 2s, and the number of 3s. You need to set up 1 for 4s, 1 for 5s, and 1 for 6s. So you need 3 more int variables here. We're going to default them to 0 so that when we start adding, we get the right total. I also have a variable for roll that's going to track the actual roll, the throw of the die. And you can use a while loop with this. Because this one I know I want to do it from 1 to many times, I just think a for loop fits it a little better. So I'm going to set up a for loop. I'm going to start at 1 instead of doing that whole 0 offset thing. Starting at 1 makes sense. And I'm going to loop for however many times the random number generator says to roll the die. As long as my counter is less than or equal to that, I'm good. and I'm going to bump up my loop counter by 1 each time it runs. Now this is another example where the I loop counter is truly acting just to make sure that I run the given number of times. I'm not using I anywhere in a printout. I'm not using it in any mathematical calculations in the loop. Unlike some of the other examples, I am literally using it to make sure that the loop runs as many times as it's supposed to. It is truly acting just as a loop counter or a turn counter here. And I'm bumping it up, of course, by 1 each time because that's its roll. So now I'm going to roll the die. I'm using that same X random generator. I'm just going to say, hey, in this case, give me a 6-sided die. Remember, 6 gives me 0 to 5, so I need to add 1 to get 1 to 6. And then I have a nice if-else-if statement. If it's a 1, add 1 to the total in the 1's accumulating variable, so I know how many 1s I rolled. Same thing with 2s and 3s. Now you need 3 more else-ifs because you need to check if the roll equals 4 or 5 or 6. So I'll leave that to you. For my own information, I just printed out the rolls. You don't have to do that. It can save you a little bit of space there on your screen. And I just put a blank line since I printed all my rolls with a print on the same line. And then here I'm printing out after the loop is done, not while the loop is running. I don't want to see the totals each time this thing runs. I only want to see the totals at the very end. And I want to know how many of each I have, how many 1s, 2s, 3s. You need to add 3 more print lines for 4s, 5s, and 6s here. But you can see some of the distribution out of this run. So that leaves me with helping you with the card program and helping you with the figuring out if a number is prime program. Those are going to be a little more involved and take a little more time, so those will be separate recordings. But the few recordings that I've done, I've lumped all of these projects, I think, into 2 recordings to help you get started so you can at least knock out a large majority of them.